Today I am going to discuss about the combination of cells. And a cell is a source of electric current, as we know. But a single cell cannot give a strong current in any circuit. So to get a strong current in a circuit, generally we combine or we take the combination of the cells. And the combination of the cell is called battery. And the combination of the cell takes place either like in series or in parallel or in mixed combination. And first I am going to discuss about when cells are joined in series. Suppose here n cells. The EMF of each cell is E and its internal resistance is R. And all these n cells are connected in series with an external resistance capital R and a key K. And in the series combination of the cell, the negative terminal of first cell be connected to the positive terminal of second cell, and negative terminal of second cell be connected to the positive terminal of the third cell, and so on. So this type of the combination is called series combination of the cell. And here small r is the internal resistance of each cell here. And total number of cells is how much? N cells. So suppose N cells are joined in series which send the current in the external circuit capital R, or external resistance capital R. When key is closed, suppose a current I is set up in this circuit. A current I is set up in this circuit here. So how can we find what is the amount of the current sent by this combination of the cell in this resistor R? Actually, our purpose is to get the maximum current in this external resistors R. So how can we find? First we will find what is the total EMF of N cell. So total EMF So total EMF of all these cells, since EMF of each cell is E, all these cells are joined in series. So total EMF is E plus E plus E plus E. How many times? N times. So total you get total EMF is equal to how much here? N. Similarly, all these means the internal resistances of these cells are joined in series. So total internal resistance is equal to NR. How? R plus R plus R plus R. How many times? 3. How many times? N times. So total internal resistance of the cell is how much here? NR. Now this total resistance of this means total internal resistance of the cell is connected with this capital R in series. So total resistance of circuit this is equal to NR plus R. Here NR total internal resistance and capital R is the external resistance. It means total EMF of the cell is NE. Total external resistance of the circuit is NR plus R. Now you can assume you have a battery of EMF NE which send the current in this external resistance NR plus R. So current I is equal to total EMF upon total resistance. Total resistance of circuit. And this you can say this is equal to NE upon NR plus R. This is the amount of the current which is sent by this combination of the cell in the circuit here. And now you see here, if we will take I is equal to NE upon NR plus R. Now there are two possibilities. First, if NR is less than capital R. First possibility is what here? If NR is less than R. It means if the internal resistance of these cells be very less in comparison to external resistance, then I is equal to, we can write here, N E upon R. N E, and now NR is less than R means now this NR can be ignored in comparison to capital R. And simply we will get here I is equal to NE upon R. And in this case, suppose is equal to N into E by R. Now, suppose we will take only one cell. Only one cell I am taking, which is sending the current in the same external resistance R, and suppose this one thing. Its EMF is E and internal resistance R. So in this case, the current sent by this one cell in this external resistance I is equal to EMF of the cell E upon R plus R. And if R is very small in comparison to capital R, if R is less than capital R, then we can write here I is equal to E by R. It means E by R is the current sent by the one cell. And in this way you can say here N into current due to one cell. It means if the internal resistance of the cells are very less in comparison to external resistance, then for getting the maximum current in the circuit, we prefer the series combination of the cells. Why? Because in this case, the current in the circuit becomes N times the current due to one cell. So this one is what here? Beneficial for all of us here. But second possibility is what here? Second possibility, if and R is greater than capital R, if total internal resistance NR is greater than capital R, if total resistance becomes very large compared to the external resistance, now NR plus R, then this R be ignored, and now I is equal to NE upon NR, and now N is cancelled by N, and you will get E by R. And again you come on this circuit here, first one. Suppose if there be only one cell, okay, then in this case you can say current due to this one cell I is equal to E upon R plus R. And if R is very large in comparison to capital R, means if the internal resistance of the cell is very large in comparison to the external resistance, when R is very large in comparison to capital R, then you can write here I is equal to E upon R. It means I is equal to E upon R is current due to one cell. And here you are getting I is equal to E upon R, which is what here? Current due to one cell. Now it is clear from this first point and second point which one is useful for you. Either NR is less than capital R or NR is greater than capital R. What you are getting here? In this case, if the internal resistance of all these cells is very large in comparison to the external resistance, and in this case, if we prefer the series combination of the cell, then total combination of the cell gives only current due to one cell. और इस तरह की कॉम्बिनेशन का कोई मतलब नहीं है कि एक सेल मान लीजिए अगर 2 एम्पियर का करंट दे रहा है तो 50 सेल भी लगाएंगे तो ही 2 ही एम्पियर का करंट देगा, जो कि हमारे लिए यूजफुल नहीं है. Due to this reason, we never prefer series combination under this case. So in series combination, when we prefer the series combination of the cell. We prefer series combination of cells when capital R means external resistance becomes very large in comparison to total internal resistance of the cell. Now, second combination is when cells are joined in parallel. And in parallel combination, now you see here, suppose n cells, EMF of each cell is E and internal resistance R, are joined in parallel between A and B. And in parallel combination of the cell, the positive terminal of each cell is connected to one point and negative terminal of all the cells be connected to other point. And in this way, you will get a battery of n cells which are connected in parallel. And suppose this battery is sending the current in the external resistance capital R and also connected with a key K. So suppose n cells joined in parallel are combined in parallel between AB and the EMF of each cell is E and internal resistance is R. Then first case here, since between AB, be careful about this one, यहाँ ध्यान देना सब लोग, AB के across सब parallel में जुड़े हुए हैं, how many cell? N cells. और parallel में हमेशा voltage क्या रहता है? Same. It means all these cells are joined in parallel between AB and in parallel voltage be same. It means between AB, the EMF of all these cells will also comes only E. So EMF across AB, how much here? E. Total internal resistance. Total internal resistance 1 upon R equivalent. Since all these are joined in parallel, so we can write here 1 upon R plus 1 upon R plus how many times? N times. It means you can write here 1 upon R equivalent is equal to N by R. 1 by R plus 1 by R and 1 by R. N times you can write here N by R. It means R equivalent is equal to R by N. It means total internal resistance of all these cells is R by N. And this internal resistance with capital R connected in series. So total resistance of the circuit this is equal to R by N plus capital. This is the total resistance of whole circuit. And what is the total EMF across AB? E. So current draw from this battery in this external resistance I is equal to EMF upon total resistance of circuit. Total resistance of circuit. And in this way you can say I is equal to EMF is how much? E upon total resistance of the circuit R by N plus capital R. And now you can write this is equal to E upon, you can write here R plus NR upon N. And now we can say here I is equal to, take this N in numerator. So this becomes how much here? NE upon NR plus R. This is the amount of the current which sent by this combination of the cells in this external resistance. And again, there are two possibilities. What is the first possibility? In this case, there are two possibilities. And what is the first possibility? If NR is greater than small r, it means if the external resistance of the cell is very large compared to the internal resistance, then at place of NR plus R we can write only NR. Then I is equal to NE upon NR. Now N is cancelled by N, and here you will get only E by R. And E by R is what here? Which is current due to how many cell? This I is equal to E by R. Current due to how many cell? One cell. Current due to one cell. And now you see, हमने इतने सेल पैरेलल में जोड़े, लेकिन ये सारा कॉम्बिनेशन मिल करके उतनी ही करंट दे रहा है जितना एक सेल देता है. तो क्या इस तरह का कॉम्बिनेशन कभी यूजफुल होगा? नहीं. इट मींस it is useless combination. It is simply, you can say, it is useless. It means if external resistance is very large in comparison to internal resistance, and under this condition, if we connect the cells in parallel, then all this combination will give only current due to one cell, which is useless. ये हमारे लिए यूजफुल नहीं है. Second possibility is what here? If internal resistance of the cell is very large comparison to external resistance capital R. Here NR means R is itself very large. R खुद ही बहुत बड़ा हम ले रहे हैं. यहाँ पे R की तुलना में इस R को हम बहुत छोटा ले रहे हैं. तो NR भी करेंगे तो उससे बहुत कोई बड़ी क्वांटिटी नहीं, ये भी छोटी ही रहेगी. So if R is very large in comparison to NR, then in this case I is equal to NE upon, now at place of NR plus R. Since R is very large comparison to NR, so we can write only R. This NR we ignore, and now we can write here N into E by R. And here you can say N into current due to one cell. Current due to one cell. It means if the internal resistance of the cell be very large compared to external resistance, then for getting the maximum current in this external resistance, always we prefer the parallel combination. So already I have discussed here under what condition you will prefer the series combination and under what condition you will prefer the parallel combination. So this one is a useful combination because here you are getting the current in the external resistance n times the current due to one cell. Suppose a one cell is giving the current 1 ampere in this external resistance, and if the 50 cell is connected here, then you will get here 50 ampere now this time here. Now third combination, cell combined in or cell joined in mixed grouping. And in the mixed grouping, what I am taking here, suppose a cell of EMF E, and internal resistance is also there. Don't forget to write the internal resistance here. It understood here the internal resistance is also there here. Suppose in each row here, this first row, second row, like this one here, in each row, n cells are joined in series और सभी सेलों का EMF E और इंटरनल रेजिस्टेंस स्मॉल r है. तो इस तरह के फर्स्ट रो n cells in series, similarly second row n cells in series, third row n cells in series between point A and B, and now in this way m such type of the rows is connected. इस तरह के n सेल सीरीज में जुड़े हैं और इस तरह के m रोज जो हैं वो A और B के अक्रॉस पैरेलल में जुड़े हुए हैं with external resistance capital R and a key K. Our aim is to find under what condition this mixed grouping of these cells will send the maximum current in this external resistance R. Now, how can we find the total resistance? First, we will try to find out what is the total resistance of this circuit. So what is the total internal resistance in each row? Total internal resistance of m rows. Here, internal resistance is R, small r, small r, small r, small r. Since all these cells are joined in series, सब सीरीज में जुड़े हैं, तो इसलिए n सेलों का टोटल इंटरनल रेजिस्टेंस एक रो में कितना हो जाएगा? nr. इसका भी कितना होगा? nr. How many times? m times. So nr is connected in parallel. How many times? M times. So we can write here 1 upon R equivalent is equal to 1 upon nr plus 1 upon nr plus how many times? M times. Because nr, all these are connected in parallel between A, B. And how many rows be there? M rows. So 1 upon R equivalent 1 upon nr, 1 upon nr, how many times? M times. So we can say here 1 upon R equivalent is equal to M by nr. So R equivalent is equal to nr by. This is the total internal resistance of this M rows. External resistance capital R is joined in series. So total resistance of the circuit total resistance of circuit is equal to, so total resistance of the circuit nr by m plus capital R. याद रखिएगा ये nr by m total internal resistance of the cells, and this one is external resistance R. And we prefer this mixed combination of the cell for finding the maximum current in the external resistance. What? When external resistance, when R is equal to nr by m. Here I am not giving the derivation for this one here. Direct I am telling you the condition, under what condition we prefer the mixed grouping. When external resistance of this circuit becomes equal to total internal resistance, then in this case, this mixed grouping cell will send the maximum current in the external resistance here. So, remember this, in series combination, in parallel combination and in mixed combination, already I have discussed under what condition we prefer the series combination or parallel combination or mixed combination. Now you remember this note here, condition for maximum current in a circuit due to combination of cell. मतलब कब हम कौन सा combination of cell prefer करेंगे किस condition में maximum current पाने के लिए. First, like the serial number, combination and condition. Like, under what condition? We will prefer the combination of cells in series. So for series combination, we prefer when external resistance of the circuit is very large in comparison to total internal resistance of the cell. And second, when we prefer the parallel combination of the cell, when the internal resistance of the cell is very large in comparison to external resistance. And when we prefer the mixed grouping we will prefer when external resistance is equal to total internal resistance of the cell. So these are the conditions for getting the maximum current in the circuit, and these are the combination which we prefer. Dear student, always remember this. We prefer the combination of the cell only for one purpose, for getting the maximum current in the external circuit here. So today you go through all these topics which already I have discussed here, and in the next video I will tell you the combination of cells in series and parallel is equivalent to what here. So suppose in any numerical problem, if the two cells are joined in series or two cells are joined in parallel with the different internal resistance or the same internal resistance, so that cell is represented by a single cell of how much EMF and how much internal resistance here. Thank you.